Hello guys, the Biweekly contest 161 has ended, and the first problem that was asked in this Biweekly contest was a split array by prime indices. So in this we are given an int array nums, and we have to split nums into two arrays A and B using the following rule. So in the first, for array A, the elements at prime indices must go into array A and all other elements must go into array B. So whatever is at prime indices in the given nums array has to go into array A, and whatever is at the composite index must go into array B and return the absolute difference between the sums of the two arrays. So rather than creating the arrays and then filling it, we will directly maintain the sum variable and add the value at the indices, prime indices, in one variable, and values at the non-prime indices, composite indices at the in the other variable. And finally what we will do, we will just return the absolute difference of the two values. That's how we are going to achieve this. But first of all, we need to find which all uh, which all indices are prime and which all indices are not prime. So to do that, what we will do, that we will create one boolean, okay, is prime, and we'll be calling a method called sieve, and in this sieve we'll be passing the value n. Okay, and as I mentioned, I'll be creating one long, and we'll just say that prime sum, initialize it with 0l, composite sum, we will be again initializing it with 0l, and then we'll be going through the indices. I is equal to 0, I less than n, plus plus I, and then what we will do, if we will check if prime sum of I, so if it is true, if prime sum is not prime sum, is prime for that indices is true, the true value is stored in that at that indices, then we will do prime sum equal to nums of I, else, okay, comp sum nums of I. And after doing all this, what we will do, that we will return the math dot absolute value of prime sum minus comp sum. That's the way it is. And then, so now the thing that is remaining for us is that we need to find the we need to complete this sieve method. Okay, so this will be utilizing sieve of Eratosthenes. Sieve of Eratosthenes. So sieve of Eratosthenes. So first of all, what we'll do, private boolean array, and then is prime, okay, and okay. Now in this, what we will do, that we will first of all we will create one boolean array which is of the size n. Okay, and if n is greater than 2, then we will fill arrays dot fill. So see, 0 and 1 indices are always non-prime, so we need not bother about that. That's why we are asking if n is greater than 2. Okay, so arrays dot fill, so we will fill the indices from 2 to n. So 2 is inclusive and n is exclusive with the value true. Okay, and then we will use two loops. So the loop will start from value I is equal to 2, because 0 and 1 are always non-prime, so we are not bothered about that. And I into I is less than n. So why I into I is less than n? Because when we are calculating anything, so we need only check till the square root of n. That's why I into n, I into I is less than n, and then plus plus I. Okay, so I should vary only till the square root of n. Okay, if now if it is mentioned that this is prime, if is prime, okay, then we will take the multiples of I. So for int j is equal to I cross I, okay, j less than n, j plus equal to I, okay, and then we will mark prime is prime of j is equal to false. Okay, and after this we will just be returning is prime. That's it. So I hope this is clear to one and all. So only thing is that we need to run this. Okay, and we will run this. So there is this error. Sieve. What is this spelling that I'm not using the method name sieve. Sieve. Perfect. Now let me submit this. So this is getting accepted. I hope you like this solution. With this, I'm thanking you. Thanks a lot. Happy coding.